In this video I'm going to introduce you to induction. Induction could be thought of a little bit as maybe say dominoes. So say the things that knock each other over. If I can prove that if the first one falls, and if it knocks the second one, and if the second one knocks the third one, then pretty much if they're all set up right, they will all fall. Another way to look at induction would be, let's just say for example, I have the key to hotel room number 1. And inside the room number 1 would be the key for room number 2. Then I have access to room number 2. And let's just say that inside room number 2 was the key to access room number 3. Then I have access to room number 3. And if that process continued, then I have access to all the rooms in the hotel. Maybe it's not the best example, but it gives you an idea what induction is. If induction can be shown to be true for certain specific values, then it can be proved to be true for all particular examples of that type. Now, the example we're going to look at now is an introduction. So, proof by induction. I want to prove, now note by induction, you must do it by induction. For all n is an element of n, so for all natural numbers, that the series 4 plus 8 plus 12 ... plus 4n equals 2n times n plus 1. So in other words, if I took, these are multiples of 4, so say I took the first 10 multiples of 4. The first 10 multiples of 4, the sum of them would be found by just substituting 10 into this formula on the right hand side. The first 20 multiples of 4, well, the sum of them could be just found by substituting 20 in there. So there's 3 steps to induction. Show that it is true for the lowest value of n available. So in our case, so for all n is an element of n, that will mean our first value is n equals 1. Now we assume it's true for n equals k. I'll come to that later. And then we prove it's true for n equals k plus 1. And the language here is quite important. So I want to show that the sum of the first 1 multiples of 4, just the language here. So show that p of 1 is true. Now, what this means is that show that the proposition is true when 1 is taken as the first value. So show that the proposition is true for 1. So if n is 1, then I'm just taking the first multiple of 4. So we're just taking the first multiple of 4 here. We're not taking any others. So 4, and then substitute 1 in for n. So do it into the brackets first. 1 plus 1 is 2, and then 2 1s are 2, 2 2s are 4. So 4 equals 4. So what you would write there is therefore p of 1 is true. And you need to put in this language. Even if you struggle with the maths of this, having the structure to your question can actually get you a lot of marks. Now the next part is the key part. I assume that p of k is true. Now, so what does that mean? It means that I assume that the first k multiples of 4. So, for example, k could be 20. So in case that would be 80, so 4 plus 8 plus 12 plus 16 all the way up to 80, would be equal to, so then I replace n with k on the right hand side. I assume that that's true. And that's my key phrase, because in induction you're always going to use this second step in the third step. Okay, you're always going to use the second step in the third step. Now, and step number 3, I prove that if p of k is true, that p of k plus 1 is true. So in other words, I go one further. So I'm trying to prove that 4 plus 8 plus 12 ... plus 4 of k, and then plus 1 more. Well, for example, if I was taking the first 10 multiples of 4, then that would be 40. But if I was taking one more. So if I was taking 10 plus 1, then it would be, sorry, and I should just replace n with k plus 1. So basically you're replacing n with k plus 1, so that'd be 10 plus 1, that'd be 44. Now, I have to show that that's equal to, replace the k here with k plus 1, and replace the k here with k plus 1. But then don't forget I've got this other one as well. Okay. Now, this is the key part. This is where you're going to use your assumption. Now, what have I assumed? I have assumed that 4 plus 8, I have assumed that that is equal to that. Now, this sequence appears on this line as well. So do we see that sequence? So I've just highlighted it here for your convenience. See that exact same sequence? Remember earlier when I said I would always use my assumption? So I'm going to replace this with 2k times k plus 1. So, but I've still got this 4 times k plus 1. And on the right hand side, I'm just going to tidy it up a bit. K plus 1 is k plus 2. So I'm just going to go over that step again. You're always going to use your assumption, okay? So I have assumed that P of k is true. I have assumed that 4 plus 8 plus 12 plus 4k can be written as that. So now I'm going to use that assumption. So see in the k plus 1, I have 4 plus 8 plus 12 plus 4k, the exact same sequence of numbers there. So I've performed a substitution. I have replaced these and I've put in that 2k times k plus 1. Now, what we have to do then is show that the left hand side and the right hand side are the same. So if I multiply this out, I get 2k squared plus 2k plus 4k plus 4, which gives me 2k squared plus 6k plus 4. Now, we have a little, is that equal to 2 times k plus 1 times k plus 2? So I'm trying to show that the left hand side can be written the same as the right hand side. Well, let's just factorize 2 out of this quadratic expression. Now, and then we can factorize again. So if we factorize this, we get k plus 2. So just ignore the 2 for a second. You get k plus 2 and k plus 1. Now, is that equal to that? Yes, it is. Even though it's not in the correct order, as we know, multiplication is commutative, which means that it doesn't really matter what order I multiply, and so that can be rewritten as that. So therefore, the left-hand side is equal to the right-hand side. So, and this is how you finish it off. Therefore, P of k plus 1 is true, assuming P of k is true. So in other words, the proposition is true for k plus 1, assuming that P of k is true. And then you would write, by the principle, and this is unfortunate, well, not unfortunate, but it's a bit long, but if you have time in the exam, by the principle of mathematical induction, so by the principle of mathematical induction, P of n is true for all n. Now, Even if you can't get that entirely right from start to finish, and I must unfortunately have to warn you that this is maybe one of the more straightforward examples of induction. You'll get better at it, but just to the 3 steps which I've put up in red here, show P of 1 is true, so you substitute in 1. In other words, you take the first multiple of 4 and you show that the left hand side is equal to the right hand side. Okay, so the left hand side is equal to the right hand side. So the proposition is true when n equals 1. Now I assume that P of k is true, so I assume that if I have the first k multiples, in other words the first 5, 10, 15 or 20 multiples, that can be found using this formula. Then I prove that P of k plus 1 is true. Now if you look, so I have 4 plus 8 plus 12 plus all the way up to 4k plus 1 more. That's where the k plus 1 comes in. So say instead of here I might have been looking for the 10th multiple of 4, so show that the first 10 multiples of 4 can be found using that formula. Show that the first 10 plus 1 multiples of 4 can be found by using this formula. So that's where the k plus 1 comes in. But then here's where I use my formula, or my assumption. See the way I've highlighted the 2 of them in the highlighter? So you can replace this with that. That's my assumption. I have assumed that this is the same as this, which I should also just maybe there put into the highlighter for you. So, and then I just multiply out the left hand side and show that the left hand side can be written the same as the right hand side. Now it might take a bit more manipulation algebra wise, but generally speaking, if you can get to there, or even if you get lost in this little bit of the maths here, you'll still have a significant amount of marks that will get you through the question and get you through in good shape with more than just the attempt mark. So these 3 steps are crucial.